So hello everybody, my name is Roberto Garcia, and I'll be talking about calculus and visual arts. But before I begin, I'd like to show you what visual arts really is. So, the visual arts are art forms that create works that are primarily visual in nature, such as ceramics, drawing, painting, sculpture, printmaking, and many other stuff. But today, I want to focus on drawing and painting, or a little bit about photography. Okay, so when you talk about calculus and visual arts, it's a little hard because paintings and art in general is very subjective. It's subjective to whoever's looking at whatever piece of art you're looking at. So what I did instead was seeing where different curves were present in different paintings and art stuff, because I think that was more interesting. See how different artists could use calculus curves to do their paintings. And lastly, I'm going to show you something they call string art, which is something very cool. I'll show you a video in the end. So first, I'll start with the Bezier curve. Okay, as you can see here, the Bezier curve is given by this equation right here, and you can see it in art in different shapes, because it depends on the n number, as you can tell in the equation, and to see how many points you have to create the curve. Okay, so it's very you can see it in, this is more in like kind of comics in the first one, and then this is more like, I don't know if you've seen music videos where they have like strings and stuff. That's the Bezier curve. It's pretty much present in most of that kind of art. So continuing, the cochleoid. I don't think we've seen this curve specifically in art class, but the cochleoid, as you can see, it has a, I don't know if that looks kind of familiar, that spiral shape, right? And it's given by those parametric equations in there. So a sine squared t over t, and x equals a sine t cosine t. And the curve is given by the different t values we can plug in there. Okay, so the Bezier curve, these are extracts from different art paintings. And in visual arts, they're very common, because as you can tell, if you want to create spirals, you use the cochleoid in order to do them, because it's much easier to have a formula you could see how it goes spinning and rotating. Keeping on the ellipse, it's a very common, I don't know if you've noticed, but it's very common in visual arts in general, because as you can tell, I mean, even, I think, correct me if I'm wrong, I think that's in Washington, D.C., in one of the parks in Washington, D.C. I mean, you can see the ellipse in many different paintings and other stuff, and this is, as I told you, I also included a little photography in it, and that's what I was talking about. You can see ellipses in art because they're very easy to draw. I mean, as well as circles. Ellipses and circles are very easy to create, and you can give them like different shapes, so that's cool. Then for my calculus project last year was the Lissajous curve. That's why I bring it in again. It's given by the equation, and it depends on the parameters inside the sign in both parametric equations. So as you can tell, Lissajous curve can have many different shapes depending on how we use the equations. And in art, you can create many different patterns, because you see here how it has kind of a cyclical shape. Well, if you as you increase the value of t and the angle inside the sign, you're gonna have way more curves that are occurring, and that's why you have like so many varied shapes in there. Lastly, the Littus curve is sort of like the cochleoid, but you can tell. Does that remind you of a shape of an instrument by any chance?
French horn.
French horn? Sorry. Violin, sort of. Okay, so you can tell there's many applications of calculus in art, even though you're not gonna calculate something to paint it, but you can tell that there are many shapes that we can study in calculus that are used in visual arts. And lastly, I want to talk about what string art is. String art is characterized by arrangement of colored thread strung between points from to form abstract geometric patterns. Okay, so pretty much, as you can tell, you can form many different patterns and cool stuff for visual arts, and that's why here I want to show you this quick video, 60-second video, that's about string arts.
There's a couple of features.
Yeah, so you're gonna notice how this guy begins. Well, let him begin. He begins by drawing a circle, right, and calculating the same distance to mark where he's gonna put the nails, okay? And then he passes a string by creating a same pattern, okay? And then, yeah. So, so that's it for my presentation. I just wanted to show you how you can actually use calculus as well as in many other applications as you can use it in visual arts.